Today we are going to learn microcontrollers practical. So experiment number 6 that I am going to show you. See, the title of the experiment is interfacing of multiplex 7 segment display with microcontroller. Now what you want to do here? Okay, here you want to interface a set of 7 segment. So here set of 7 segment means we are considering here 4 segments are interface. Okay, you see the diagram here. 4 segment means are interface with your microcontroller. Now if you see in on platform, on railway platform, there is a board, sign board, there is a board. Okay, over that you can able to see multiple 7 segment are get placed over a single board, and you can able to watch a message over that. Okay, that message is a still message or a running message. Okay, so with the help of a microcontroller and with the help of a single port, see what is the beauty of this interfacing is, here we are using only a single port of the microcontroller, and we get display multiple character over that. So that's why here such type of interfacing is popularly adopted in most industrial demonstrations. Okay, I hope if you go through the Swatantra Chowk, there is a one LED's in display is there, as well as near Natras Theatre also there is a such a signboard is there, that is made up of 7 segment. Okay, also if in a railway platform also, whatever the railway coach number are displayed, as well as the information given to you over the platform, that signboard are also made up of these 7 segments. So keep it in mind, the such a 7 segment board, huge 7 segment, industrial point of view, huge 7 segment means there are near about hundreds of 7 segments are interface with single microcontroller. Okay, so here I am telling you here one of the prototype of that. Okay, so here only 7 segment are interface with microcontroller port. Okay, in case if you want to extend it, so you just connect the multiple 7 segments and use this same circuitry for that. Okay, so here if you observe in this circuit, 7 segment are interface, their A, B, C, D, E, F, G and DP line are connected with the one ULN driver IC, that is 2803 IC. Okay, its output terminal, that is out 1, out 2, out 3 up to out 8 are connected with this A, B, C, D, E, F, G. Similarly, the ULN, okay, here what is the ULN? One question may arise in mind, that what is ULN 2803? ULN is one of the amplifier. Okay, whatever the signal which are obtained from the microcontroller, okay, that will be near about 5 to 50 milliampere. Okay, but for driving of such a huge number of 7 segment, it required current amplification. Okay, as well as it will maintain a voltage level. Okay, so that's why constant voltage and current requirement point of view, such type of ULN driver are get interface with microcontroller to keep a boosting of current as well as voltage level of the signal coming from the microcontroller. Okay, so here it has 8 input like IN0, IN1 up to IN8, and similarly 8 output, that is out 0, 1, out 2 up to out 8. Okay, so here IN1 are IN1 to IN8 are interface with the microcontroller port, that is a port 0. Okay, or it may be a port 1, it may be a port 2 or 3. Okay, it depends on you. Okay, so microcontroller here in this diagram 89S52 is shown. Okay, similarly the P1.0, P1.1, P1.2 and P1.3 from the microcontroller port 1 are 4 line. These 4 line are connected with the base of the transistor. See, if you look base of the transistor, like 5 BC 548, 4 transistor are connected to CA terminal of the 7 segment. okay, that is giving the supply, okay, that is a plus VCC terminal with 7 segment. So in that the plus VCC is directly connected to the plus 5 volt, and in between VCC and VCC of 7 segment a transistor is connected. What is its purpose? The purpose of the transistor is to turn on or turn off the 7 segment. Okay, here the base will be responsible to turn on the 7 segment or turn off the 7 segment. Okay, so most of the cases such circuitry is used with VCC of the L7 segment or the ground terminal of the 7 segment. Okay, so it will be depend on the designer's design, so that's why they will adopt whether to where connect that transistor, whether it is now in this circuit it is connected with the VCC. Okay, and most of the designer may adopt that transistor will be connected with the ground of the 7 segment. Okay, no problem, there is no issue, both circuitry are same. Only the difference, major intention of connection of this transistor is to just turn on the 7 segment or turn off the 7 segment. Okay, question is how you can turn on that segment. Okay, so that's why here remember base of the transistor is 0. When base of the transistor is 0, that time the transistor is off. Okay, and when the base of the transistor is 1, that time the transistor is on. Okay, so most of the cases here now 4 line are taken from the microcontroller port. Okay, these lines are directly connected to the base of the transistor, but most of the cases there is a decoder circuit, that is 2:4 decoder circuit, and that decoder circuit will use between these terminals for conversion of 2 to 4 bit. Okay, so that's why I am showing you the truth table. Okay, see, whatever the truth table that I am showing you here, okay, that will be based over only 2 lines. Okay, so that's why here 2:4 decoder is utilized in this truth table. Okay, means here P3.3 and P3.4 is utilized as per our EDSIM simulator. Actually that diagram I have taken from the internet. Okay, actually the internet diagram and the EDSIM diagram are not matches. Okay, but here just for understanding the concept point of view, here I have shown you that diagram. Okay, but remember the circuitry is very similar, only the difference is that instead of utilizing that port 1 line, here port 3 line are utilized. Okay, and it is connected with the decoder, so that's why here decoder is present. Okay, so 2:4 decoder is utilized. Okay, when P3.4 and 3 both are 0, that time the first one 7 segment, okay, means whatever the first segment is there, okay, means in the diagram again I am showing you. Okay, in this diagram here we consider the segment 1 will be this one, segment 2 will be this one. Okay, means D1, D2, D3, D4 are written. So D1 means display 1, display 2, display 3 and display 4. Okay, so in same fashion here I have written the decoder output, so that's why display 0 turn on point of view, which bits will be necessary? When P3.4 and 3 both are 0, that time the decoder output will be high, and as the decoder output will be high, display 1 will be on, but at the same time other display, display 1, display 2 and display 3 are off. Why? Only the transistor of the display 1 is on, and as it turn on, only the VCC is connected to the 7 segment, first one 7 segment, and the remaining 7 segment are disconnected from the supply. Okay, so that's why this is the beauty of this circuit. Now when you change the bits position from 00 to 01, okay, you will see display 1 will be on. When you change the position of the bits again 10, then display 2, and for last segment, okay, last bit 11, then display 3 will be turned on. Remember, keep it in mind, all segments never turn on at a time. What I said, all segments never turn on at a time. Okay, only one segment will be turned on and all remaining segments are off. Now question arises, sir, how I can display the message? See, I am showing you here a message, okay, that you can display. Same message will be displayed on the all segments, okay. And here you can able to read, okay, you can able to read a continuous message, okay. So that's why as this is a simulator, so that's why in the over this simulator, now I am copying this program, okay, whatever program I have given you, okay, I have given you two sets of program. First set of program is displaying the digits, okay, and second set of program is displaying the number, okay, 1 2 3 4, okay. So here for demonstrations point of view, I just put it one over that, okay. So I just copied that program, okay, and here I introduced some amount of delay also, okay. Now in case if you run it, okay, if you run it, you can see one is continuously displayed over all segment, okay. Means here if you look the circuit, okay, if you look the circuit, this microcontroller ports will be putting, microcontroller is putting one over that ports, and that one is get passed to all one segments, okay. Means here only single port is utilized, and single port is interface with all segments. So that's why one is displayed on first one, second one, third one, and fourth one. But here due to this simulator restriction, okay, see, due to this simulator restriction, I cannot show you one on all segments, okay. But in case we have hardware, you can see one get displayed over all the segments, okay. Means you can read one number over that segment, okay. So here some speed matching problem is with simulator, so that's why here I cannot show you full demonstration of this, but now you can understand here port can single port can able to display the message over that 7 segment, okay. This is the beauty of multiplex 7 segment, okay. This type of program are most prominently adopted in industries for displaying their messages, okay. In case if you are taking the example of multimeter, then also you can able to see voltage, current, okay, resistance, impedance, okay. All these values are displayed unstable fashion, okay. But behind this, that's the same concept is adopted, okay. So keep it in mind, okay. So in this fashion you can perform this experiment of multiplex 7 segment display, okay. Getting everyone? So I hope you are doing it in your home. So best luck for you. Now I am taking your permission to leave this experiment, okay. So just watch it and do the practical again, okay. Thank you very much. Thank you.